anybody you think would benefit. This is Daily Data by 1 Million Women to Tech, where we encourage women to learn data science in 2 minutes a day. Let's get started. Today we'll talk about false positives. A test for a certain disease has the following accuracy. If someone has the disease, the test will produce a positive result 99% of the time and give a false negative 1% of the time. If someone does not have the disease, the test gives a negative result 95% of the time and gives a false positive 5% of the time. The disease itself is quite rare, occurring in just 0.3% of the population. A person is picked at random from the population and tested. He tests positive. The critical question is, what is the probability that he has the disease? By the way, please comment here below if you think I should change the example to a lady and use a she pronoun or they pronoun. We need to translate this into mathematics. So let X be the event that this person has the disease. Before we factor in the test data, we know that P of X is 0.0003 or 0.3%. Let Y be the event that this person tests positive. Now we can split this event with what we have learned in the previous daily data to write this as P of Y equals the probability of Y given X times probability of X plus probability of Y given not X times probability of not X, which comes out to 0.99 times the probability of the disease plus 0.05 times the probability of not having the disease. And this is roughly 0.5%. We are really interested in P of X given Y, the probability that the person has the disease given that he has tested positive. And we can work this out by using Bayes' theorem, which we saw a few days ago. If you need to go back, you can check in the previous topics here. You can also navigate to the daily data probability lesson and then dig down into false positive. So if we express this using Bayes' theorem, we have P X over Y. X given Y is P Y given X times P X over P Y. And now we can use what we calculated. So 0.99 times 0.03% times this probability is 0.056. So the probability that the person has the disease, given that they tested positive for it, is a little under 6%. The explanation for this surprising result is that the true positives from a high proportion of a very small number of disease sufferers. These are greatly outnumbered by the false positives, a fairly small portion of a hugely larger number of non-sufferers. Yeah? So despite the seeming accuracy of the test, when randomly chosen people are tested, actually a large majority of the positive results will be false. Maybe one of the good homeworks would be for you to draw out an example and compare the sizes of the positives, false positives, negatives, and false negatives. All right, we will see you tomorrow. And if you would like to go through this and understand it better, please create your free account at 1millionwomentotech.com, going to the request invite, which will create your account and give you access to the course. Thank you so much and see you tomorrow.